Hi, this is Aaron from Sibling Rivalry, and today we're going to be doing a few handy mods for your Kingroon 3D printer. These mods are also useful for any other 3D printer similar or even sometimes dissimilar to this.
Can make copies of almost anything.
Welcome back from the intro. So, just to clarify what exactly we are modding today and doing with the Kingroon printer, I know myself, as well as several other people from the forums and the Facebook group, have had issues with the power adapter. So, there's a few different variances of this issue. It's usually with the socket here. I'm going to see if I can get a nice little shot with my phone. We're going to do some B-roll live. All right, so yeah, a lot of times the little socket there is either too loose or the actual plug itself. Let me see if I can grab that. Oop. The plug itself is loose, like there will be a weird connection, like mating issue with it, so it'll wiggle around a lot and it doesn't connect. Essentially your printer the power will drop at random, and that's a kind of a really bad issue, to say the least. If your power continuously drops on the printer, even the power recovery won't help you at that point. Like, I've tried printing something last night, I believe, and it kept dropping out every like 10 minutes. And after a few times of the power dropping, if it drops a couple times consecutively, it corrupts the recovery file, so you can't actually recover the print anymore. And sometimes it actually doesn't retain the correct spot for that recovery, and then you end up with the print head driving into a print that's already partially completed, like it'll plunge into the actual plastic. So we're going to be modifying the board here to have a better socket, and there's plenty of ways you can do this. I just found these, I found a pack of female and male DC jacks online, and that was on Amazon for a couple bucks. We'll link them down below. I also grabbed some jumper wires here, which I took the headers off and I just flattened them and put them in the terminal block part here. You could technically modify this any way you like. You could switch out the connector altogether. I might be switching out the power supply, because I've noticed with my two printers, one of the power supplies, it's actually the male section, like the, let me see if I can grab it, like this guy itself is the problem. And I don't really want to cut off the head and then swap it out. I'd rather just get a different power supply altogether. So I might do that in the future, but for the immediate future, I am going to be using one of these and connecting it through manually, and we'll probably show some B-roll footage of that. Another thing we're going to do to optimize your printing speed, potentially, or your quality even, I bought a pack of different nozzles online. Some of these are actually, well, one of these is actually from another printer. I just threw it in the same bag because it seems dumb to have multiple bags of nozzles. But I grabbed these on Amazon as well for, I think, $8 for 5 different sizes. It came with duplicates of the 0.4. I know the printer itself comes with a replacement 0.4 nozzle. But what I'm going to be doing is changing it to a 0.8 millimeter nozzle, and that's going to increase my flow rate and my print time. I'm doing a few fairly large prints right now that it'll help with, and it'll be good for doing like big bulky parts. With my other printer, I'm probably going to change the nozzle to the 0.3 or something similar to that. Like something smaller than the 0.4, so I can get a bit of a higher resolution print. It will take longer to print with those because reduced flow rate through the nozzle, but it, yeah, I'll have essentially, I have 2 machines. I'll have one for each purpose that I have. So first we're going to replace the power connector, because we're going to need that to replace the nozzle, because you need to heat up the nozzle to be able to remove it. So we'll set these aside for right now and we'll get started on this. So the tools that I have here, other than the parts that I showed you, I have a adjustable wrench or spanner, depending on your terminology and whatnot. You could get one that fits the, we're essentially going to grab one that fits the heater block for this, so you can hold it in place. You could find one that's the right size, but personally I just have an adjustable one because I have a few different printers and you never know what the size of those blocks are going to be. They're not exactly standard between designs. I also have some edge cutters. These aren't the ones that came with the printer, but they're another pair that I had just lying around. I have a pair of needle nose pliers and a pair of, I don't know what to call these, just like blunt pliers, like bulldog pliers maybe. I've got an Allen key driver set. You could also just use different screwdrivers or different Allen keys. And I've got my multi-tool just in case. It's always good to have. It's got a little screwdriver on here that actually fits the screws on this terminal block perfectly. So let's get started. So what I'm going to do first, actually before I do anything, is take out the SD card on this printer. You can tell I've just started this. I've actually clipped off the filament from the spool. So there's just a bit of like floating filament in here. We'll remove that in a bit. So just make sure you don't have that attached because it'll just be a pain in the butt. So what I'm going to do now is just start unscrewing these side screws. We're going to be doing, start out this one and this one, and we're going to do this one and the other guy back here. You can remove this if it makes it easier for you, but really it shouldn't make a big difference. And we will go to the bottom in just a second once I get these ones out. And we're going to be removing, there's essentially a screw that lines up with these pads and the front, and that takes off this metal cowl. I'm probably rambling a little bit. First time recording a video in a little while. We've both been a little under the weather. We had a bit of a backlog for a while there. And yeah, with these screws, you don't want to remove them entirely. You can just loosen them until they're kind of the heads wiggle. The ones on the front here by the Z set screw, these you can actually remove entirely. You just loosen them and then slide them up. Ooh, helps if I loosen it a little more. And there we go. I know we've gotten a few comments, complaints, requests for better B-roll, so we're working on what we can. We're not a huge channel. We don't have like any like crazy funding or anything, so we're doing what we can with what we have. I'm gonna just take off the magnetic build plate just for the sake of it, just to kind of simplify things here. And now I am going to try and set this in a way that's not going to damage the table. Okay, so, and that magnetic build plate actually makes a good pad. Let's see if I can get a shot of that for you guys. So yeah, it's good to prevent it from like denting your table if you're worried about that. Okay, so we're gonna be removing this guy and I believe this guy. Yeah, and then we're gonna be removing these bottom two, those guys there. So let's see if we can zoom out a little bit more. Yeah, if you need any clarification on this, I'll probably post some additional pictures on the Facebook group, just showing where these screws are located. You don't need to remove a lot of the screws because, like, the more screws you remove, the more your printer is just going to disintegrate. This acrylic plate on the bottom actually seems to hold most of the printer together. So let's take these out. If you have an electric screwdriver, this would actually be an excellent use for that. Just setting the screws aside. They're all the same length here, these 4 screws, so you don't have to worry about mixing them up, thankfully. I think they're just M3 screws, so you could even swap them out with like a flathead socket or like a socket head cap screw if you got one of those. They're doing the like the pan head or the dome head ones so that they're a little more flush and they don't stick out as much. But with these giant rubber feet on the bottom, you should be fine. And now we're going to pick this up, flip it back this way, and this should be, I'm just going to slide this back. Oh, I missed a screw. My bad. Let's set this back. Oh, yep, there's a third screw right there. So, remove that. You can tell where the screws are because there's little flaps bent over on the sheet metal. And that's where they've got like a threaded little pad for these screws to set into. So, exciting stuff. All right. Now, I'm just gonna wipe off the table a bit before we get too much of a mess. These things kind of like to drop metal flakes, I've noticed. And now you can just slide this off like so. And there's a ribbon cable here for the LCD. What you want to do, I'm going to see if I can get a better shot of this. We can just set it off to the side like that. Okay, so there is the ribbon cable. And you want to actually slide out this black plastic part like that. So, slide that out, ribbon cable pops out, thing falls over. You don't want to just pull the cable out because it can actually damage the registration on that and you'll have issues putting it back in. You can print without the LCD, but the LCD is required for printing headless without a computer. Now is also a good time to kind of clean out whatever bits of stuff have fallen into your printer. All right, so there's your standard power jack, the one that you would normally use. This terminal block right here has the exact same connection. So these are interconnected. What they're doing here is actually using the power input from this jack to go through, and it goes all the way through these ribbon cable sort of things, the sleeved cables, and it goes into here and powers this fan. So they're essentially just running the fan directly off the 24-volt supply. So what we're going to be doing is taking our little guy here with these wires, and we're just going to be splicing it directly into that. So we can use this to have a steady connection. We don't have to worry about this jack anymore. We can just ignore it. So this isn't like the tidiest way of doing this. You could do it a lot better. You could probably get like an actual solderable version of this or some heat shrink, which I'll probably do in the future. But just for a quick instant fix, this is an option. So, oh, and I had someone ask me about the socket for this Wi-Fi, because like there's a socket here for like a Wi-Fi chip. So it is the ESP12F, if that helps anyone. It's usually the it's ESP8266, and the module is the ESP12F. I went through some data sheets for this board, the Robin, like the MKS base Robin Mini V2, and they verified that it's the 12F module that is compatible here, and it should be just drop-in compatibility. So if you're looking for that, I might do a video on that in the future. I don't really see a huge point in doing Wi-Fi on this printer. I already print with an SD card, but it might be worthwhile. I don't know. It would be something to play around with. So just going to be connecting the cables. Not really anything exciting to see here. You just want to make sure you get the polarity right. So I'm not using the right colors for cables here, but it does have the polarity listed there. The positive is on this side if you're facing the screws, and the negative is on this side. You can thankfully see the polarity on both the circuit board as well as the wires coming out of it. So I'm just going to use that, and we're essentially going to have these go in right beside the fan cable there. So this is where the multi-tool comes into play. I'm going to move the head over so we've got a bit more space to work. I'm actually going to slide this guy up. If you didn't know, you can actually push that. It's a little tough, but not impossible. Now, they say you shouldn't do that because it does create a charge across the board, but as long as you're not doing it like constantly and like forcing it or like pumping it, it should be fine. It's not gonna like supercharge your board or fry anything. So what I'm gonna be doing here, I'm just unscrewing these little terminal blocks just a little bit. I'm just gonna do one at a time just so we don't end up messing anything up here. I'm gonna play it safe. So blue is our negative. So we are going to shove that into that hole. Actually, I think I need to squish this a little more. So I'm going to use these pliers just to flatten this into a nice flat connector. There we go. And now that is all in there, we're going to tighten it up. Now, someone's probably going to comment on how you should be doing this a different way. You could take the board out and make sure that everything's in there and it's not going to come loose. But what I'm going to do is just do a quick pull test. Everything is gripping. That means that it's making contact with the plunger on the terminal block. And for right now, that's good enough for me. Now, obviously, this mod bypasses the safety or whatever in the jack, but as long as you are smart about this, you should be fine. Again, I should state, though, that I accept no liability for anything that happens as a result of you doing this modification. You're modifying the printer against its initial specifications, and you're using it outside of its initial specifications. So don't do this if you're worried about it. If you're having issues with that jack, contact the seller and they should be able to replace it for you, like replace either the board or the printer with one that works. But if you're like me and you're a tinkerer, then feel free to do this. Okay. Now this one's a little trickier. I'm going to use some pliers just to kind of hold it and get it in there. I'm just trying to do this the least invasive as possible, so not taking the board out, because taking the board out is a bit of a pain. I've done it on one of these and I did it once and that was it. So yeah, just holding it with the needle nose, tightening it back up, and we're gonna do a quick pull test. That's in there, and we're golden. So what I'm actually gonna be doing is feeding this alongside the little barrel jack here. So we're gonna feed the wires through the panel. So what we're gonna be doing is actually taking the head off of this, just keeping the polarity in mind that yellow, or whichever color you pick, is positive and blue is negative. So best way to think about that is warm color hot, cold color cold. Yeah, yellow happy, blue sad. Don't touch it when it's on, otherwise both colors sad. But yeah, so we're gonna, yeah. So yeah, just unscrewing it on this end. Just take those off. We are going to reconnect this ribbon cable, essentially just follow the steps that I showed you earlier backwards. Feed it in there. Kind of shimmy the socket part in, and then just make sure that it's actually in all the way, and you should be good. Yep. And then we are going to put this, feed these wires through there, and then set this on top of everything like it was before. As it was, so it shall be. And
Let's just see if we can get everything to fit nicely in here. Now with these wires, they are pressing up against it a little bit, but let's see if we can adjust this a little better. It's okay, I see what's going on. It's trying to feed it around the bottom of the board. You just got to make sure that you keep this as tidy as possible. Just maybe coax it a bit, and there you go. We have those wires coming out. We are going to just reverse everything, tighten these guys up first. The great thing about these lock nuts for the extrusion, they are the type that automatically adjust themselves. So you'll notice that the lock nuts come out if they're in this orientation, but not in this orientation. The way that these are designed, they actually have a twist on them. Let's see if you can see that there. So as soon as you start tightening it, it actually spins itself and locks it in place, which makes it super easy. They used to make these sort of lock nuts without that spinning function, and you would have to like have a thing in there to hold it in place. Otherwise it would just kind of spin inside of the channel on this extrusion, and then you wouldn't be able to get it back in there. So thankfully they're using the new ones that do that. When I say new, I mean like relatively new in the sense that 3D printing is new. 3D printing has actually been around since the 70s. So okay, that guy is in there. Looks like, oh, no, he is not. I don't know how it got away with that, but it snuck out. Okay. We're going to tighten both of these. Yeah, it probably would have been better to use a screwdriver here, but I made my bed. I will sleep in it. Okay, so there's that guy. He's in there now. And we're going to do reverse of before. Slide this way. Set it on the mat so that it doesn't dig into the table and my sister doesn't kill me. And yeah, just put these screws back in. Nothing too exciting to see. Again, if you have an electric screwdriver, which I think I have one sitting in my backpack and I should have grabbed it before this, it'll make this way easier, but then you won't have as long of a video to show on YouTube. We said yellow is good, otherwise known as positive. And we'll tighten that in. And there we go. And blue is negative. All right, so now we cross our fingers and hope that nothing explodes. I'm going to connect up the power supply here to this jack. All right, let's test this out.
They say electrotherapy is really good for the brain. All right, so just kidding. I'm not electrocuted. So yeah, I switched out the power supply. The one that didn't have the broken jack. It turned out the jack was broken on one of them. I don't know how that happened. I didn't do it. I haven't done anything that would have broken the jack. It was like the actual plastic was like melted and misformed and stuff. Let's blame Duncan. He takes the fall for like everything. So, yeah. Now we are going to change the nozzle out. So I'm just gonna slide this over to me. Gonna rotate. Slide this up a little bit. And, okay. So, this will be interesting. Not that anything else has been like non-interesting or interesting to begin with. We're going to grab these nozzles that I set off before. We don't need the multi-tool. We don't need the edge cutters anymore. We just need the wrenches and the pliers, the wrench and the pliers. Allen keys we will need just to remove 2 screws here. I will take a quick video of that. All right, so we're going to be taking out this screw, and that'll take off this whole metal cowl here. And we're just going to kind of set it over the top a little bit. So we want to have a bit of space so that this can hang over the top. We'll show you that on both cameras in just a sec. And we're just going to unscrew that. Thankfully, all of the screws that we've used, or all the screws that we've removed and replaced, are all 2mm heads. So they're either M2s. I don't think they're M2s. They're too thick for M2s. They're like M3s, but the head is a 2 according to this. I don't know. We'll see if we can get a better measurement of that for you guys. But they are M3, so as long as you have an Allen driver that's compatible with M3 screws, you should be fine. And maybe they're 2.5s actually, because they seem a little smaller than the M3s I'm used to. So to take this guy off, once you got those screws out, you just kind of lift it this way and unhook it and just place it over the top like that. So there we've got the heater block accessible. You're going to want to adjust your wrench so that it fits this heater block. I already have it there. I don't know if all the heater blocks are the same with these, but yeah. Just get an adjustable one, I guess, unless you've measured it out and know exactly which size yours is and that they have a wrench that size. So what I'm going to be doing is just going into the menu here for preheat, and we're going to preheat the nozzle. Okay, so we're going to go in and do preheat. And we want this to go up to 180, so we'll set it, we'll set it 185 just to be on the safe side. And it's going to start to heat up, and we're just going to wait for this guy to get up to temperature. Essentially what we need to do is get this to heat up enough that we can pull the filament that we've got here out, like do like an atomic pull or whatever you want to call it. Pull it out of the Bowden tube. You can see all the dust on my Bowden tube. Lovely. And once we've done that, we are going to hold on to this heater block. Don't touch this while it's hot, Aaron. And then take the pliers and hold on to the nozzle and undo the nozzle. Essentially, sometimes you want to loosen off this block so that it reduces tension on that nozzle, and then you can unscrew the nozzle easier. Other times you can just unscrew the nozzle, but yeah, it's starting to get hot. Let's see. It is 188, so we shot over a little bit. Okay, so we should be good to do this. I'm going to take this guy this way. Let's expand it a little bit. Crack it off like that, like I said before. And then I'm just going to use these for right now, the Bulldog pliers, and grab the nozzle. And we're just going to loosen it. It might take a little bit to do this.
I am loosening it, right? Sometimes it's hard to tell with these. Yeah, I'm pretty sure I'm loosening it. Let's check. Yeah. Okay. Oh yeah, I need to pull the filament first. I'm an idiot. Ooh, everything's stuck. Okay, there. All right. So, I have pulled out the filament there. You can see it's got the little bit that's like the nozzle. It makes like a little plug where the melt zone is. I'm just gonna set this scrap off to the side and we're gonna resume this. I'm actually gonna, no. I'm gonna raise this up a little bit again. It kind of came down earlier, just to give us a better angle of everything. And if you have a wrench that fits this, it makes it way easier. I know these heads tend to be socket wrench compatible, but I don't have a socket wrench on me right now. That's why I'm just using the needle nose pliers, which work fine. You can use bulldog pliers, which I did earlier to loosen it. I did that because it gives a nice grip to kind of break that initial friction. And there we go. We've almost got the whole nozzle out. Okay, so there are a few different ways you can do this, but you do want this to be warm when you're removing it, otherwise you might just strip or snap these brass nozzles because sometimes they aren't super good quality. You can see there that it's kind of plugged with plastic, which we'll clean this out in like an oven or something later, or a blowtorch to clean it out. It'll burn off the plastic. So now I'm going to go into this baggie, dump these out, and grab our 0.8. I'm just going to find that. It's a 0.4. That is a 0.2. There's a 0.5. There's a 0.4. 0.8. Probably would have been easier just to look at the holes and see which one has the largest hole. Put everything back in here. And this guy's probably a little toasty still, right? Yeah, a little toasty. Not terribly hot, but definitely don't want to put that in the bag or hold on to it. So I wouldn't suggest doing this way, but I am going to just start this by threading it by hand. You definitely want to make sure you don't burn your fingers here. And the brass is going to heat up pretty quick, so you want to go quick. Don't burn yourself. Don't burn yourself, Aaron. There. That's just hot enough that I don't want to touch it anymore. And we will tighten this in again. Super exciting stuff. I don't think it's moving anymore. Let's see. Okay, so now we just kind of tighten this, square everything up again. See if we can just kind of grab this and lock it a little bit more. And there we go. It should have a good solid fit there. Yep, good solid fit. And we're just going to replace this cowl. So we're just going to put that back on there. Same as it was before, just line up the holes. Find the screws that you misplaced on your desk. And just kind of tighten this all up again. And you want to make sure that if you're changing the nozzle size, that you go into your slicer software and update the nozzle size in there, because otherwise you're going to have some really weird issues and you're probably going to break your printer. because it'll not account for the flow rate change. And yeah, it won't be fun. So that's on there, nice and solid. And let's see if we can feed this filament in and make sure that we've got a nice flow in there. Oh, apparently I hit the switch and it turned itself off. There we go. Let this heat up again. I'm just gonna bypass that switch. I've noticed sometimes when I hit the filament runout switch that it shorts out the, well, not shorts out, but like disconnects the power. I think it's like a fail-safe thing if you trigger it too many times. So I'm just taking my snippers from before, cutting a slight angle into the filament, and we're just gonna feed that in. The reason we do that slight angle is so that it goes into that Bowden fitting a little better. So, what is going on here? Does not want to work with me today. Not that that's different from any other day. Okay, I'm going to try straightening this out so that it's not curving as it's going in there. So what you can do is you kind of counterbend the filament. If you're finding that it's too tight, like if you're getting near the end of your spool, you can counterbend, which is essentially bending slightly against the curve, like a little more than straight, and then it straightens it out. It takes into account the elasticity, I guess, or plasticity of the filament, and there you go. Fed that in. Let's see if we can feed this all the way in. And of course the nozzle has cooled down because that power outage earlier. So I'm going to get this up to 190. I'm just priming the nozzle essentially. So I'll take this guy now. He should have cooled down enough. Yep, he's cooled down enough. This was the 0.3 nozzle, which I'm probably going to end up putting on my other printer. Right now I just need 0.8 millimeter for doing big prints. We're doing some like soap dishes and trays and stuff like that, some stuff for around the house. And we are up to 190 now, so let's feed this through. Oh, that is a nice big chungus of an extrusion. Let's see if we can get a nice shot of that for B-roll. That is satisfying. Very low pressure. And there we go. Once you've done that sort of prime, it's good to pull, like just immediately pull the filament out, which will give you it'll clean the nozzle. So you can actually see here this little rat tail on the end. Let's see if I can do that. That's actually from inside the nozzle itself. If you do this near the glass transition, so like around 70 degrees, it takes a lot of force, but you can just rip it out and it will clean the nozzle. They call it like an atomic pull, which I think I mentioned earlier. But there's some interpretive art. I call it time. This is the shape of time, even though time's a flat disk. But yeah, that should be good. I'm going to go update some G-code on my slicer and see if we can print some big, huge, fast prints. So if you enjoyed this video or found it informative, please give us a thumbs up. We really appreciate that. If you liked it, also, thumbs up. If you're not subscribed, please subscribe, because we're going to be doing some new content with the printer soon. Multicolor stuff and a few other things where you've got some TPU somewhere around here that we're going to be printing once I do a modification to this extruder, which we'll show on video as well. I'm going to be modifying the power supply to replace the faulty connectors on it. And yeah, got some other stuff as well coming up. If you are subscribed, make sure that you ring the bell for notifications so you don't miss out on any of our new content. Like before, we post content regularly on Mondays, and we have bonus content on Thursdays. And yeah, I hope you enjoyed the video again. Thanks for watching, and have a great day.